Alright, time for another draftphysics.com video presentation. There I am. Alright, so another video against the conventional religion that they call physics. And so I'd like to be able to have this as a interactive conversation about, well, here's some logical points. Do you have a response? Now, I've been talking about the two slit for years and years, and pointing out these defects. So this is like a 5-year argument, and I can't get a single response from anyone to any of these points that I have raised over and over and over again, responding to Feynman videos and Looyen videos and this guy Paul Looyen videos, and nothing. They won't engage in the conversation. They won't concede that first somebody could actually object to anything they're saying, and then they won't deal with any specific objection. They just pretend there's no argument to be made. So I'm just using him, I'm just pointing this out, okay, and I have to use these people as example, and I'm just saying they're so obnoxious that they don't care that the future is going to weigh this and say, gee, why weren't any of these people willing to engage in this conversation? Because it is just a matter of faith. It's a matter of again, something like the Inquisition. They don't want to hear that the universe doesn't work the way they think it works. It's the same thing they did to Galileo and all the other people who just dared to say, hey, I have a better answer. Okay, there is a better answer than your silly answer for how the universe works. And that's all there is here. So they'll mock flat earthers, but in a sense they are the flat earthers, okay, because they won't allow anybody to point out how their theories are poorly reasoned, poorly founded, poorly evidenced. They won't acknowledge even the existence of the possibility that those are facts, that they don't have enough evidence to be convinced, and there is, in fact, obvious defects in what they say. So I'm showing this image first just because this is a classic piece of the the stuff they should be able to figure out all on their own. The source of the two slit, okay, is always a tiny little aperture, okay, less than a millimeter aperture. So it's a tiny little thing, and a long distance away, by comparison, that is thousands of units of distance compared to that distance away, is where they're projecting the image. Alright, so you can understand though, this doesn't change. This tiny distance, 1 millimeter, doesn't change. So Professor Lewin's done it, Feynman's done it, they've all done it. They all say, well look, the two sources in the middle have to be constructive because they're equidistant lines. Those equidistant lines are happening inside of a millimeter. On the screen, it's even less than a millimeter, but you're going inside of a millimeter. So on the screen, it's a point. Everything that happens in between this millimeter, every single thing that happens inside, where both things are pointed in the same direction, has to happen in less than a millimeter of space on the projected screen. So the projected screen has a pattern that's a foot long, and we're talking about something that takes place in a 1,000th of that distance. It wouldn't even be perceivable. You couldn't see it, what's happening inside of that space. So obviously that can't be relevant. And and the simple argument is this is what you're really doing. These two lines aren't the important lines. These two lines are the important lines. How much is this space here, okay, screwing up the space over here, creating the wavelengths of difference? So if you know it's not a whole wavelength going this way, you know it can't be a whole wavelength going in the center. And these are just simple mechanical logical arguments that point out a defect in the story they're telling. They're telling you a narrative, and then they have a talking fish or a talking tree, some sort of Wizard of Oz bullshit. And you point out how that doesn't happen in reality. Okay, that might happen in Oz, but that can't happen in reality. And they just won't engage the argument. They refuse. I can't pay them to do it. I can't humiliate them to do it. They refuse to defend their physics because it's a religion. It's not science. All right. So, we'll do a little bit of this first, just pointing out more of the defects in their logic and reasoning, and then we'll play him talking about how they've proven it. Yeah. When, no, they haven't done any of that. This angle is not perfect. Not the, these little details are kind of important, and I really should work a little better at them. Alright, so the single slit, they never show it, but I mean it can create two different patterns depending on how wide the slit openings are. So you can have the single impediment experiment here where the light travels here on the sides, right? I guess I should show the light. No, that doesn't very bright. Yeah, you can't really show with that writing implement. It is funny, these aren't compatible. The dry erase of one brand leaves a film that makes the other brand not work. Alright, so the light is going on these two surfaces and light's going through here. Now all of you what you really can understand about these experiments is all it's really doing is creating scatter in one direction. The light goes in, I should put that up here, and basically it scatters it, that way and that way. It's scattering sideways, not up and down. So that's kind of how polarizing works, is that you're scattering the photons in one direction. Scattering the elements that make up the photon. Let's understand that too. So these two are single slit. Okay, the single slit can look like either one of these things. They'll pretend and call it, oh, it's a diffraction pattern. Well, at least Professor Looyen's honest enough to say, no, it's not a diffraction pattern. These patterns, whatever they're created by, are created by the same thing. Now, I'm obviously arguing it's not interference. Nothing interferes in the space. The photons don't interact with photons. And that what the real interference is with electrons on the surface, and it's completely controlled by the surfaces. So, but anyway, what they don't explain is this, okay? There's a double maxima. They avoid any explanation. They don't have one, because it doesn't really go with their two-line theory, okay? So that doesn't work. And they clearly, in the double slit case, they don't take any account for the fact that, yes, there are the two patterns here. So the two forms of the single slit show up in the double slit. It's not a double slit pattern and a single slit pattern. It's really just the two kinds of single slit patterns. So if you have a very narrow opening, you get this pattern. If you have a very wide opening in a single slit, you get this pattern. And all you're really doing in the double slit is creating that circumstance. Here's your very wide distance here, and here's your very narrow distance here, or yes, it could be here and here. So the smallest distance is creating the big pattern, and the biggest distance, the most wavelengths of difference, right? There's a huge difference between the length of this line and this line, right? This is the one with a lot of wavelengths of difference. That's creating the little bar pattern. And you can know exactly how many of those little bars there's going to be by just calculating this arc from here to here, and then calculating this arc from here to here, and that'll tell you exactly how many points that are possible candidates for putting light back in phase and out of phase, in phase, out of phase. The number of wavelengths that fit in the distance will tell you exactly how many bars per side. And it perfectly explains why there's a double in the middle, is because there's two nodes. Two of these are combining with each other into one node. And that's why it's always, okay, an odd number in the middle and even numbers in the side node. Well, it's not even numbers in the side nodes, it's just that this one's always odd. So you could have, well, I guess these have to be even. You can have 6, and this will be 5, and then this will be, if I have 4 here, that'll be 8. Yeah. So there'll be 7. Yeah, so it is always even and odd. No, it's always odd here, and it can be even or odd here. Okay, yeah, that's the way to say that. So, it's you can reason this out, that the real point to take away from here first is they don't explain these patterns at all, and the Young diagram completely abolishes the pattern because it really just says there's only 2 point sources. It takes a 4-point source experiment, and because they make the slits infinitesimally small, or they put an infinitesimally small wire in the middle, they basically eliminate the fact that there were 4-point sources, because they put 2 of the point sources so close together, okay, that it's the same point, realistically. So, these are the point sources, the surfaces. It's a surface experiment. All the fringes are created by photons that interact with the surface. The surface has electrons on it, and it's clearly understood that electrons scatter photons. And that's what's really happening here. So it's not proof of waves at all. Particle theory can perfectly explain. All their storytelling is just that. It doesn't fit the evidence. It doesn't match the evidence. It doesn't do respect to the truth. It disrespects the factual, actual truth. All right. So, in that context, we shall play the video. Or parts of it, anyway.
I know that light.
Oops. Okay, I have to get rid of this so you can see that.
Is a wave. And more specifically, it's an electromagnetic wave.
Okay, so he says it, we have to believe it. All right, that's a little too fast. Speed up. So no, it doesn't have to be a wave. And frankly, it doesn't make any sense as a wave, because you start talking about radio waves being miles and miles long. It doesn't work. And what you can't understand is I can snap my fingers, and I can wait a while, and I can snap my fingers again. And you can understand that that sound can have great distance between it, because it's a pressure, and then there's no pressure, and then there's pressure. And that's what light is doing. There's a particle, a bit, and then there's no bit for a while, and then there's a bit, and then there's no bit for a while, and then there's a bit. And that's the way light travels. It travels at a frequency of events. Events with a period of time between them. That's the wavelength. There is no wave. There's just periodic events.
But what evidence do we have that light has wave-like properties? In the 17th century, there were 2 ways that light was presumed to travel. Now, Isaac Newton was a proponent of one of them, and he believed that light traveled in what he called corpuscles. Basically, that means bits, or particles, and
Yeah, so again, and how he thought about that exactly is just like how we would assume Einstein would think about it. You don't really draw their vision, and they don't really draw their vision. But the simple argument I could make is that we could say light is made out of these things. So if you really read what Einstein says, he's basically saying it's made out of corpuscles, but the photon itself, okay, is made of the quanta. The photon isn't quanta. The photon is made of things, okay, with a separation of distance between them. That's the wavelength, is the distance between the events. So a photon could be 3 events, it could be 5 events, it could be 500 events. Now, I'd argue that it's probably somewhere between 2 and 5, but we'll see. But that explains what a photon is.
Attempted to explain various phenomena such as rainbows, reflection, refraction, and so forth in terms of his...
Yes, he did it in terms of straight line vectors, okay? So it wasn't even so much the corpuscle part. He just showed that you don't need a wave to do it, because all you're really talking about is a starting point and a landing point. And things bounce like rubber balls. The thing basically obeys these rules, where the light actually does go in at an angle, comes out at an angle, like as if it was just a rubber ball hitting something at an angle. That the momentum is conserved in a sense. And you can't do that with a wave theory. You can't even have stuff land in one location with a wave theory. Wave theory doesn't do too well in explaining how a laser beam works.
Corpuscular theory. Now another guy, Christian Huygens, who is likely a fellow Dutchman, and we were both born in The Hague, believed that light travelled in waves, much like waves travelling through water, and he developed his own explanations for the same phenomena, but now in terms of wave behaviour. Now, in this video, I'm going to specifically discuss what is commonly known as the double slit experiment, or Young's double slit experiment.
Right, and it's commonly and always misdescribed as some sort of diffraction experiment, and then there's the diffraction envelope and the interference pattern, and it's just a bunch of mush. And then you have silly explanations of what's actually happening in the space. And then other experiments, again, I've pointed this out, but using radar and using radio waves kind of decisively point out that this has nothing to do with photons banging into each other and interfering, because you can do the experiment from two directions where the waves can never interfere. I can take two radio signals and I can have the place I'm going to measure, the antenna, in between them, and I can create the same pattern. And yet the waves never interfere with each other. They never interact with each other. They never come anywhere near each other. And yet I get the same pattern, indicating this isn't about waves interfering. This isn't about water. Water doesn't do what light does anyway. It doesn't work. It doesn't do the double slit pattern. It only creates two waves in the double slit pattern in water. The single slit does that.
First performed by Thomas Young in 1801. And this experiment at the time became the defining experiment that refuted Isaac Newton's corpuscle view of light.
All right, so it didn't refute it in any way. So all of that didn't happen. It doesn't provide any argument. And again, the drawing is a canard. It's just a lie. It's not the double slit pattern that he saw. If you use infinitesimal slits or an infinitesimal barrier, you're destroying the surfaces. So you're turning a 4-surface experiment, the double slit, into a 2-surface experiment by putting two of the surfaces so close to each other they're not different anymore. You can't have a wavelength of difference between them because they're so close together. There is no place where there's a wavelength of difference. That's all he did. Young turned a 4-surface experiment into a 2-surface experiment and then pretended it was a double slit when no, it isn't really.
And ultimately became the methodology to demonstrate the wave nature of not only light.
So again, you just keep saying it. It proved the wave nature, the wave nature. No, the particle theory is still perfectly viable. It's just that none of you like it. And that's the bottom line. This is about what you like as a theory. It isn't about what you can defend as a theory. Now, it's unfortunate that Einstein couldn't, he didn't spend enough time in a laboratory, I guess, really looking at the double slit and playing with it to realize some of these obvious flaws in the Young analysis. That it's such an obvious defect when they start saying, well, the slits have to be smaller than a wavelength. Well, if they're smaller than a wavelength, there can't possibly be any constructive or destructive interference created from those two sources. Those two surfaces become irrelevant. If you make a single slit smaller than the wavelength of light, yes, you get a blob of light on the screen because you've eliminated the potential for constructive and destructive interference. It's all a surface experiment. The surfaces are in the math, the distance between the surfaces. I mean, how can you deny that simple fact that that's exactly what you're measuring? You're measuring what happens between two surfaces.
But also
the surfaces are the sources.
Other forms of electromagnetic radiation, sound, and really surprisingly, matter itself.
All right, so that's all part of your fairy tale, in my opinion, okay? This idea that matter itself is waving, that electrons are waving, that everything's in a wave mode. There's no decisive evidence for any of this mush. And clearly it can soundly be argued that it's not. It's just that mush. The Bohr model of the atom, you won't allow there's never been some place where people showed up to have the great debate about whether it makes more sense to have a magnetic model of an atom, a charged model, when we already know charge exists. We already know electrons and protons attract and repel, and that you could arrange them in positions where the whole thing becomes static if I get rid of, gravity or other forces to mess it up, that I could actually arrange magnets in positions north and south and have the whole structure stay in one piece. So magnetic model of the atom works. I don't need swirling electrons. I don't need any of that stuff to make a model of an atom that works, where electrons can be shared. So none of your theories, none of your arguments have been proven by some decisive volume of evidence. You're just all a bunch of believers. Okay, you don't need much encouragement, to believe. You just want to believe. You just don't need to see the videotape of the wave walking on the water.
You're going to have to watch my video on matter waves, and I'll provide a link in the...
Yeah, well... yeah, sorry, it's not going to be a very good, argument, because it's going to, again, be a perversion of the evidence, describing the evidence as overwhelming when it's less than whelming.
Description below. So let's have a look at the double slit interference in action. So here I have a helium...
Alright, we can probably skip this, right? I mean, we don't really need to see how you set up an experiment to just take a picture of a pattern. The point will be, it's there. That's the best image he has, pretty much. And obviously it's poor in the sense that, okay, you can see the 3 nodes here, you see the 5 here, right? So it's 1 less than twice 2 nodes. So it's obvious, it's pretty much obvious that these are 2 nodes smashed together. Alright, and then you have the single 3 bar, 3 bar, 3 bar. Now it ends up looking like 2, 1, because it's getting dimmer and dimmer. But clearly there are better photographs of double slit experiments where you can see the nodes continuing out the sides. Alright, and that each node is 3 bars. Alright, and the math dictates, and the geometry dictates that, because you're applying this to a circle that ends up being parallabic, in the sense that these bars get wider and wider as you go around. Alright, from the center, and you go around equidistant. Right? So that's the other thing. They project this on a flat screen and pretend that the distance doesn't have to be a curved line. The radius has to be, the L distance from you to the target, from the slits to the target, has to be the same distance. So when you're measuring the bars that are going off to the right and off to the left, you have to bring them closer and closer, because the distance to a flat surface is not the same L. So even simple things like this, like where you should say this pattern should be projected on a curved surface. It shouldn't be projected on a flat screen, to be honest to it.
What you can see are a series of...
Let's see, that's way too loud, I think.
bright and dark areas. And this one here is the position of my original dot. And
so again, he's trying to make this point that somehow that pattern is being created by the millimeter, less than a millimeter, right? He's using very small slits, so it's like a 10th or a 25th of a 0.25 of a millimeter. And he's pretending that this stuff is going, this way and landing on the target and create. No, it can't possibly do that. The only part that was going where both the vectors were going in the same direction is such a tiny pinhead inside of that little first circle. You couldn't see it. This pattern has nothing to do with anything going towards each other between the two slits. It has to do entirely with two vectors that are going in the same direction. Okay, it's all fringe light, and it's all created by the surfaces. Photons that go by the surfaces end up fringing.
And then on either side you see a dark region and then again bright regions. And what's happening is we're getting constructive interference at each of the bright spots and destructive interference.
So all we're doing is phase and out of phase. That's the key word. So it says that anything to do with constructive and destructive, it just has to do with, are they in phase, are they out of phase? Is the frequency restored or is the frequency broken? That's the key point.
interference at the dark spots. In other words, light is reaching from either slit on both of those dark spots there, but because they are out of phase, they are cancelling out, and so we're getting...
Okay, they're not canceling out, so none of that's happening. They're out of phase, therefore they can't push the electron because they're not resident to adding energy to the atoms. They can't add energy to the pieces of the atom, the electrons, because they're not swinging, they're not pushing the swing in the right order, the right timing. It's like pushing a kid on a swing. You can't add energy if you push when the kid isn't there. Right? Do I have to really explain that? That if you push at the wrong time, okay, when it's coming towards you and you push, you're defeating adding energy. And if you push when there's nobody there, it's not going to add energy. And the whole point is why we see photons, okay, is because they reflect their energy, all of it, okay, for us to see one, or it's absorbed, okay, as heat or some other movement. But the real detectors, if we're going to make a detector, we are detecting it with electricity. When we terminate a photon, we detect its energy because it creates electricity.
These dark spots. So what we're going to do now is we're going to measure the distance between the first bright spot, which is...
Okay, so we don't need to do any of that because that math is already established. The Jungian math is already established. We're measuring distance between surfaces. And the Young math just does it by taking a 4-source experiment, like I said, and turning it into a 2-source experiment. That's, so yeah, you're just measuring one distance. And yeah, that geometry works, that math works. But it only works in this special circumstance where you've destroyed 2 of the surfaces in terms of taking point sources that are far away and made them the same place. Alright, so probably we don't need this. It really doesn't tell us anything.
The best estimate I have is point...
Okay. So yes, all of the math, there's no objection to that as an understanding that this really is in the math. It's about the distance between surfaces. And the flaw they make in their analysis is simply ignoring the fact that, yes, in the double slit, the measurement is now the outside dimension. The 2 furthest surfaces and the 2 closest surfaces give you the math you need to define where the little bars will be and how big the envelope will be. How many little bars will you have and how big an envelope pattern will you have will just be determined by the shortest distance between 2 surfaces and the widest distance between 2 surfaces. That logic works perfectly to describe the pattern. Alright. So let's go to his model. Well, we'll just put this little
8 of a centimetre or 8 millimetres, and we're going to use that in our calculation. So before we start looking at the mathematics of double slit interference, let me provide you with a...
The mathematics is just geometry. So you're just saying, again, if I take there's 2 surfaces, I could draw a line to the over here at 90 degrees or whatever you want to call it, 180 degrees. And you can just understand that the length of the line from one surface and the length of the line from the other surface basically tell me all I need to know. Because it tells me exactly how many wavelengths will fit in that distance. And if it's a uneven number, like 14.4, if there's a remainder, 14.4 wavelengths, well then I know this spot, okay, is going to be an off. Because it's almost perfectly 0.5, which would be a half a wavelength. So I know here is off. And then if I want it to be on, I just say it's 15. So as long as if it's a whole number, then this will be an on. If it's not a whole number, this will be an off. And we know the pattern going up is going to have to be consistent. So we know the center can be on or off. The real center.
Simple demonstration to show why we get regions of constructive and destructive interference. So what I have here...
So we have in phase and out of phase, and he keeps saying constructive and destructive interference. And in this example, he's basically, I've showed this before, but he's basically showing us a landing condition. This interference is supposed to be happening in the space itself. The photons are supposed to be colliding with each other and interfering with each other. It's not a surface phenomenon. That's not consistent with the Young drawing of the waves interfering with each other in space. Okay, so he doesn't. I've used this as a way of understanding the experiment, and it's fundamentally flawed because yes, you're not doing this center thing. So you have to understand that you're really just talking about two arcs, one starting here and an arc starting here, but they're only a millimeter apart. But they're really distinctly two separate patterns. All right, and so you don't need the wavy lines. All you need is a line that has notches that show you how a wavelength of difference. So if he just made these two red lines were just regular straight lines, and he just put black knots on them, at these locations, then you could just see that when I move them around, the knots will either line up or not line up. Where the knots line up, I have a wavelength of difference. Where they don't line up, I don't. And the real argument is you don't want these as Einstein said, quantum energy quanta. You don't want these energy quanta to hit at the same time. What you're really saying is you want them to hit at the right period, the right distance between impacts. That's what you're trying to create. You're trying to recreate the frequency that the distances are breaking. The fact that the photons are now traveling, instead of they're not traveling in straight lines anymore, they're traveling in these bent lines, and you're trying to reconstruct the frequency. You don't want them to land all at once. That's not a frequency. You want them to reconstruct the frequency.
Is a very simple demonstration to help you understand how interference works. And I have these two rays coming out from these two pins. Now the pins represent...
So he called them rays, but obviously it's not a coherent description of a ray. How does the ray know to keep doing this stuff? And what's the physics of that? Motion without a cause is what that is.
Slits, and you'll notice my two rays are completely in phase, and we've of course got the same wavelength. So as a result, you could argue that these two rays are coherent, they're in phase, and of course the same wavelength and frequency. And the line...
And the real point is, though, is the frequency is the landing, how it lands in a location. The period between these bumps is the real definition of a photon.
Here represents our screen. Now in reality, of course, if light is coming out from this slit, then it's all of these rays occurring, and that will produce us these wave fronts that are...
Oh yes, but what isn't occurring is these two going in opposite directions. That's only occurring inside less than the distance of a half millimeter.
Concentric circles, and that's true for this here.
Okay, so again, that's just completely unnecessary and useless. Yes, if I just draw straight lines with dots representing the distance of the frequency, I can make it look like round waves. I can make a line, and I can make another line, I can make another line, another line, I can put little dots on them, and you'll see these same little arcs, but nothing's waving. Particles can look like waves. Waves can't look like particles.
As well, but we're only going to examine two of them so that we can see what happens when they actually interact or interfere with each other. Now there is a point right in the middle, and that's this point right there where you'll not...
Right there, and that happens inside less than a millimeter of distance on the target. It's totally unperceivable. Every bend that happens where these two lines are going in opposite directions, all of that happens on the target inside of less than 1 millimeter of distance. It's clearly not creating the pattern. So that's the deception of the fact that you can't really demonstrate the experiment you can't make a scale model, okay, because you have to create huge giant distances and little tiny distances in the same image, and you can't do that. But you can understand that that's the rule, and you should explain that's the rule. That both of them meeting in the center thing is a canard. It has nothing to do with the pattern. It has nothing to do with deciding whether the middle bar is going to be in phase or out of phase. It's completely deceptive because all of that happens in less than 1 millimeter on the target.
Notice that we have complete overlapping and they're completely in phase here. And that means this wave and this wave add up. We get constructive interference, and so we're going to get a nice bright spot right.
Yeah, we're not. Okay, you're just going to get inside of 1 millimeter. There's a nice bright spot. But it has nothing to do with the real nodes. The real nodes are here, and the excess other node is over here. And it really just depends on if they're out of phase, then they're going to separate a little bit. If they're in phase, they're going to overlap more. So you're really just talking about how much they overlap. They're definitely going to overlap because it's less than a millimeter of distance between them. So they're overlapping, and what you're really going to see are two nodes overlapping. So you have nodes that are a certain size, they just meet in the middle and they overlap a little bit so it looks like one node. Period. Simple explanation. Explains exactly what we see. This mush doesn't.
There. Now, if I, however, move this one in that direction as well as that in that direction, you'll notice the common point, and that's roughly in this position over here.
So none of this happens, right? So that's still inside of 1 millimeter. So you have no bars inside of the one tiny little millimeter on the screen. There's no constructive and destructive interference happening. There's no pattern. All of that is happening inside of 1 millimeter on the screen. You never see it. So all of that is nonsense.
Where I've got, let's say, the downhill section of one and the uphill section of the other, they're cancelling out. So that's out of phase right there. So we're going to get a dark spot there. But if we move along, we'll find there'll be another spot, and it's roughly in this position here, where... and
so he still hasn't gotten to them both going in the same direction. So he still isn't out of that 1 millimeter on the screen. So the pattern's a foot long. He's talking about what's happening, in a space you can't see.
And because of my little setup here that's not completely aligned, not perfect, but nonetheless we're getting here constructive interference. How do I know? Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 and a half wavelengths here. And I've got 1, 2, 3.
Right, so you could just be dots and you could count the dots. And yes, it'll just keep going. One side will have 12 dots and the other side will have 10. And then it'll be 13 dots on one side and 9 on the other side. So yes, it'll keep getting, one line gets longer, one line gets shorter, until you go all the way sideways and you can see, oh yeah, one line has to be a certain number of wavelengths, and there's only a certain number of wavelengths that fit in the distance. The number of wavelengths that fit in this distance right here between the two slits, you just divide your wavelength into that distance and you'll know exactly how many bars will be created. It tells you exactly how many bars going this way and then exactly how many bars going that way. Just count the distance and multiply by 2. Done. You've completely figured out what the pattern's going to be, essentially. Now the only trick is, again, as I stated, is the bars get bigger. All right, they get larger and larger as you're going towards the 90 degrees.
3, 4, 5, 6, 7, 8 and a half wavelengths here.
That is, you can make less difference. You can make a lot of difference here between the length of the lines, but once you start going further and further down this way, each bit of distance makes less and less difference because of the slanted triangle. So the triangle has a much bigger volume when you start up here at the top. It has the biggest volume, and then the volume of the triangle you're making gets smaller and smaller and smaller as you go down the slope, and the smaller volume of that triangle means you're making a smaller difference in the length of the lines.
So you've got now a path difference of 1 full wavelength. And so that there becomes a bright spot because we're getting constructive interference at that point.
Right. So right here, I'm just saying, it's just a huge flaw. So, they're not going to pretend. They're pretending this is rational. It's not rational. This drawing is not rational. Because the real fringe pattern is going to be created by light moving in the same direction from the surfaces, not in opposite directions.
If we keep going that process along, you'll see that eventually...
Now he's got them both going in the same direction. So now he's doing the real pattern now. Okay. That's where the real pattern starts.
I'm going to get a point where I'm going to get another one. And I'm going to get one that's sitting, let's say, here. Let's have a look at the path differences. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 from this side, and 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this case is...
Right. So you're just saying it has to be a whole wavelength because that's how frequency works. You're trying to restore the distance, the period between the impacts. And you have to do that by having them line up. But when they're hitting the surface, it's not about them hitting the surface at the same time. It's about them hitting the surface with the right period between the impacts of the quantum.
Clearly a path difference of 2 wavelengths, but they're in phase. We're getting constructive interference, and so therefore we have a bright spot.
So there's no constructive interference. It just isn't a thing.
Over here. And of course that's going to be mirrored on this side as well. And again, as we said, it's because the waves are arriving in phase. And where they're arriving out of phase, as in a different...
So again, it's just about you could just think of it as machine guns that shoot at a certain time. And so it's the same argument. If there were just machine guns and they shot the bullets at exactly the same time, you're just saying when are they restored to creating the frequency, the right frequency hitting the target. And so it's either in phase or out of phase. That's it. There's no other argument here. So it just really doesn't have to do with waves interfering constructively or waves destructively. It just has to do, did you restore the right frequency?
Of half a wavelength. So say in here we've got a difference of about half a wavelength right there. We're going to get destructive interference here, and so we're not going to get any bright spot, right, like so.
Right. So the argument is that what we need is an experiment where they actually detect the energy, the heat absorbed by the surface, and see if there's just as much heat, okay, or even more heat on the dark spots where the photon doesn't coherently reflect as a photon, or something like that, or is the whole pattern pretty much invisible as a heat signature? If you can't see the pattern as a heat signature, well then you know that the photons aren't destroyed. They're still hitting the surface. They're just not in the right frequency to be seen as a photon. The energy's still hitting. It's just not at the right frequency to see it.
And so that should help you. Now let's move this out of the road. Why we get these bright spots, one in the dead center, and then of course successive ones as we go on.
So again, he's just pretending this makes sense because he's not going to show the real pattern. He won't explain the double maxima, and then he won't explain why there's 2 patterns in the double slit. The real double slit experiment creates the 2 patterns overlapped. He doesn't touch that subject at all. It's a classic feature of the double slit pattern. He showed the classic feature, right? He showed the double slit pattern where it has 5, then 3, then 3. He showed it, but he won't explain how this logic explains it.
1 wavelength difference, 2 wavelength difference, and of course we'll get 3 wavelength difference. But because this one here is now traveling significantly...
You can't use 2 wave math to explain the double slit pattern. It requires 4 waves. The only hope you have of explaining the double slit pattern is to concede there's 4 waves, and the 4 waves have to be right on the surface. The center of the wave has to be right where the surface is. That's the only math that'll get the right answer.
Further than this one over here, what we will find is that the intensity of these particular spots will decrease. Now,
yeah, and the logic there would just be, well, of course, because if the whole pattern is dependent on deflection scatter caused by electrons, the electrons only scatter the light in increments. They can't scatter it 90 degrees. They can only scatter at 10 degrees with each electron you hit. So yeah, the number of photons that hit a sufficient number of electrons to be scattered at 90 degrees might be at all, by pragmatic, practical fact, impossible.
Now, it's not going to be nice and clean. Chances are we're going to get a really bright spot over here. It's going to peter off, and we're getting a sort of a bright spot like this.
So this is the big lie also, that this has something to do with the real pattern. Obviously the pattern can have, I've made patterns that had 70, 80 bars in them. Okay. So this isn't an accurate description of what the pattern looks like. That is, oh yeah, we have a little blob here and then a blob and then a little bit of a blob. The pattern he actually showed isn't what he's drawing here.
And then it's going to get a sort of bright spot like this. That is, it's going to be obviously a little bit of destructive, constructive interference, and it's going to be not a clear spot, but a more of a spread block.
Right, well this doesn't have anything to do with the double slit. So you showed a pattern that had 5 in the middle and then 3 over here. Are you drawing that? No. But you can't do it with these 2 waves. It doesn't work.
So to speak. And of course that's mirrored on the other side as well.
This is what a poorly insulated...
Yeah, yuck. Commercials in the science videos. Just another one of my bizarre... I find it just so impossible to believe. They're using an electronic voice to read text over the commercial. You're just saying they're buying a commercial on YouTube. They produced it. It's a video. And they can't even find a person with a reasonably decent voice to just read a paragraph of text. They have to have a machine do it. I mean, damn, the world is fucked. And it's, of course, by a solar company, you know, selling the sham. Yeah, put your stupid panels on a roof and get 30% efficiency. Isn't that what you do with technology, is try to get as little efficiency out of it as possible? I mean, you don't want to maximize their performance by putting them on a farm that moves with the sun. No, put them on your roof. Shit.
In that, let's do a bit of mathematical work, and we'll use what we learned to determine the wavelength of my helium neon laser.
Alright, so this part you really don't need, because the math really is just a complete defense of it's all about vectors, it's not about waves, so there's just going to be vectors in his math. And again, the deception is that 2 waves explain the double slit. This isn't the double slit pattern. Okay, the double slit pattern has the 2 patterns superimposed. So this is all just a lie. This is not what double slits do. Double slits do not create this pattern unless the slits are so close together it creates just one point source. I mean, you have to be able to understand, if I take 2 points and put them really close to each other, it's the same vector line. I can't make the line any longer. I can't make the line from this surface longer than the line from this surface, a wavelength of difference, if I don't have a wavelength of difference in the base of the triangle. If the triangle doesn't have a wavelength of difference in its base, I can't make 2 lines where one is longer than the other by a full wavelength. It's not possible. I can make the lines 1,000,000 billion miles long, and I still won't have a wavelength of difference.
Is our perpendicular distance to the screen. We're going to...
Alright, so, I mean, there's really just no point, because this is a lie, okay? It doesn't work this way. You want to accurately describe the real double slit pattern, you have to use 4 vectors from each of the surfaces. So here's a close-up of it. Again, 2-wave theory will not explain the double slit pattern. So anytime you see the pattern he showed, which is 5 nodes in the middle, 3 nodes on the side, 3 nodes on the side, anytime you show that pattern, this mechanics can't explain it. 2 waves don't create that compound pattern. It's just a lie, frankly. Alright. So, and you don't need to do all this sine theta stuff and tangent and small angle approximation. You don't need to do all of that crap. It's really completely unnecessary. All you have to do is measure the distance from this surface to this surface. That'll tell you how many small bars you're going to have, and then find the smallest surface, you know, in this case the slits, and that surface will tell you how big the envelope is. How many lumps will be in the total envelope pattern. That's it. That's the accurate, factual way the experiment works. So this is just, again, their classic interpretation. It really just is the same interpretation. It's just they don't have these vectors in the right place at all. It's just, again, it's a lie. And most of the time, frankly, this D number is usually the distance between the impediment. They use the impediment in the middle, that distance, to be the D, not from the center of the opening and the center of the opening. But again, if you have infinitesimally small slits, that is, slits smaller than a wavelength, it doesn't matter whether you measure from this side or you measure from that side, because the distance is smaller than a wavelength. It can't make any difference to the length of the lines, because the difference in that distance is irrelevant. But the wider you make these slits and the more elaborate the pattern gets, the less this math works. And I mean, it fails catastrophically, frankly. As soon as you open the slits and create a real double slit pattern, this math doesn't work. And it doesn't work, like, obviously.
So if I were to redo this calculation and say I was actually going to estimate it at 9 millimeters, my new wavelength now becomes 6.23.
Right. So obviously, yes, the wavelength is completely controlling the distance between the bars. Red light will make big bars, blue light will make small bars. I mean, completely understandable. How many wavelengths fit inside the distance? Obviously, the smaller the wavelength, the more wavelengths fit inside the distance, the more bars you're going to have. It's perfectly consistent with a particle theory. I don't know if there's anything else in this closing.
Separation is still the same. My length is still the same. So my separation between the maxima has to get smaller as well.
So again, he has the L in here. So the key to the L is that's the difference. That's the distance from the surface you have the slits on to the target. Obviously, that distance has to be a radius. So you have to project this on a curved screen to actually see the real, to get a real feel for the pattern. Now obviously it projects the same number of nodes on the flat screen, but I'm just saying the flat screen creates the illusion that it's an infinite pattern, and it's not. It's a very finite pattern that happens within these 90 degrees.
So in other words, my spots will look like this. Now,
and so it would be so much better, right, when he had that on the screen. Sorry, you might not even be able to see it, right? It's on the edge of the screen. Well, anyway, he had the little blobs here, and it'd be so much better if he curved them just to demonstrate there's a finite number. There's not an infinite number.
If I were to look at blue light, my spots would be closer again still. Now, this is not particularly obvious, but what if I were to have all three lights at the same time? Well, then, of course, we'll get...
Well, that's actually Young's double slit experiment, frankly. He did it with white light, so he did get them blobbed on top of each other. So he was really seeing the single slit pattern with non-monochromatic light, which meant he saw just really blurry blobs. Not exactly detailed analysis.
These sort of spots like this. But you need to remember, what we see is a combination of those colors. So this, in essence, is white light. And when white light passes through, the different aspects of white light will produce interference patterns that are different. Now, if you look carefully in this section here, we're getting red, but we're not getting any green and very little blue. Over here, we're getting a sort of combination, but on this end, you're going to get blue, but not any reds and greens.
Right. So I'm just saying that's already a known, and like I said, that's exactly what Young saw, was color shifted blobs.
As you move further and further apart. So a double slit interference pattern, if you use white light, which is a combination of all the colors
all right,
coming
so he did it again, all right? I mean, I don't want to just keep bragging, but I mean, frankly, he did it fucking again. So it's as if he never did this experiment. Look at this again. He's got the two lines going from the tiny distance between the slits, right? It's inside of 1 millimeter. The white light will be invisible because in here won't be visible. That tiny bit of white light will be overwhelmed by the rest of the pattern. And clearly the rest of the pattern is going to be much whiter than he's showing. He's showing all this color separation. That's not how it's going to look. It's going to look very white in the middle, and it'll be red on one side and blue on the other side. That's how these bars are going to look, and then the bars are going to get really fuzzy going out, but you're not going to see them anyway. So by the time you go enough nodes to create real separation between the blue and the red, the pattern's going to be so faint that you won't be able to see it anyway. But it's definitely going to look blue on one side and red on the other side.
Then you're going to get your rainbow effect here. So that's Young's double slit experiment.
All right, so that's a religion, okay? It really is just a fable, a story, okay? Talking fish. I mean, he could explain, well, our only explanation is that, you know, there's this Copenhagen phenomenon and the light is superimposed and entangled, and he could make up all the other wacky stories that go with this crap, and then he could start talking about antimatter and antiparticles and then dark matter and all kinds of other woo space, you know. But that's all. Look, he's got the drawing of the silly waves on his shirt. He's all about the wave. All right, that's his Jesus. I'm not arguing for Mohammed. I'm saying there really is no Savior coming. There's, you know, there is no Messiah. That's all a fable, okay? God didn't have any children. He didn't impregnate any women. It's all a fable, okay? The real universe is mechanical. It's made out of stuff called momentum, you know, and it's just bumping particles, frankly, okay, all the way down. It's just little hunks of momentum banging into each other by very strict rules, and it's not very complicated in its elemental function. There's nothing that behaves like a snake, okay, for no reason. You know, just because it does elementally. Elementally, there is no concept of pull, and elementally, there's no concept of wave. Alright. All of that crap, anything that looks pulley or anything that looks wavy, is just an emergent defect. It just looks that way. It's like scales, fingernails, beaks, all these things being made out of, say, the same thing. They can look the same, but they're not the same. It's just so annoying. Well, anyway, I might as well just play the ending.
And it provides the definitive evidence that...
Okay, it's not definitive evidence. It's nothing even close to definitive evidence. It's so flawed and so feeble and so weak and so, you know, undefinitive, so unvisual, so incomplete. So, oh, this only works when the slits are infinitesimally small. So 98% of the possible slit configurations aren't included in your theory. Oh, you've explained the 0.0001 condition, but not all the rest of the conditions. I mean, it's pathetic to call this as you've made some complete proof here. Ugh. Terrible.
Light behaves like a wave.
No, it doesn't. It looks like it a little bit. A little tiny bit. It doesn't even look like it much. Okay, just a little tiny bit. It doesn't look like it at all in the single slit. Single slit in water waves, no interference, just nothing. Okay, one big wave comes out of the slit, it lands on the surface, no interference pattern. Doesn't look like it at all. Multi-slit, no, you know, diffraction gradient, none of that stuff happens. You don't get all this separation, none of that crap happens. So it's all an illusion and a delusion.
Now, as I've noted, the fact that we only have two slits means that the separation between the maxima is quite small, as is the angle. What would happen?
Yeah, we only have two slits, and the separation between the maxima is very small. What does that even mean? It has nothing to do with how many slits you have. It has to do with how much distance you have. How far apart are the slits? And how wide are they? That changes the pattern.
What if I increase the number of slits to 3, 4, or many more? Well, we can do that.
Right, and then you'll find out more and more that this really is just a number of point sources. So as you increase the number of point sources in a space, you're decreasing the amount of distance between the point sources, quite obviously, right? So if I have 5 lines inside of an inch, the distance between those sources is wider. As it gets narrower and narrower, I'm making a smaller and smaller envelope pattern. I mean, it's less and less nodes to the envelope. And that's what I'm really doing. And so I'm really just creating blobs of light at great distances from each other. So the more lines I add, the more point sources I add, the closer the point sources get to each other, which means I'm compressing part of the pattern. But the fact is now that I'm using an inch instead of a millimeter, some of the distances are really far from each other, so I'm making really tiny little bars. It's just that all the little tiny bars will all be in one place.
That leads us to a concept called diffraction gratings.
Yes, and it's not diffraction. It's the same exact thing that's happening on the surfaces in the double slit experiment. So whatever you want to call it, the fact is what you're doing is scattering the bits of the photon, and you're scattering them in one dimension.
Where we can have hundreds or even thousands of slits per millimeter. And this provides large diffraction angles for much smaller distances and much finer details that gives us greater precision to determine the wavelength.
Okay, well, whatever. What it does is, yes, it's making one part of the pattern bigger and one part smaller.
And that's going to be the subject of my next video, so stay tuned. So I hope that was helpful.
All right. So I don't think there's anything else to say here about this. So in those patterns, all you're really saying is when do all the point sources go to a location, then you'll have a photon. And when the point sources are all out of phase, you won't have a photon. Same rules. Oh, don't need to do that. All right, so I think that's enough of a video. Yeah. Alright, so I've made my points. They won't be responded to. They won't be countered with any argument. They won't be defeated in any way as being wrong or a poor analysis. There won't be any drawings, and there won't be any explanation. There'll be nothing. Alright. Because these people are religious fanatics, and religious fanatics are cowards. They really, they go out and shoot somebody who says their religion is shit. That's their attitude. And these people aren't any better, frankly, in the sense of their minds are just as closed. Yeah, their guns aren't got as many bullets in them, but they're just as draconian in their fear of the truth. Okay. So... yes, they won't engage. Okay, I mean, I put a link or as a response video, and it's not showing up on his video, so he's clearly ignoring my counter arguments willfully, so frankly, these people deserve to be humiliated, and that's what posterity is going to do: is humiliate them as scientists, because they're showing profound cowardice. They've been offered more than fair compensation to make an argument, and they won't make it. They won't defend their religion, okay, against my arguments, even if I'm willing to pay them much more than their time could reasonably be described as being worth. Because they're cowards. Okay, they're not scientists. They're cowards. I'm just trying to provoke, what I'm entitled to, okay, which is to be proven wrong, or demonstrated wrong, or at least argued wrong in some kind of reasonable manner, and they can't do it. So, till the next time and such, this has been... yeah, I could do an update video, but yeah, we'll save that for a separate video, what's been on the website lately. But yeah, still making videos. They're on the website. If you don't understand how it works, I make a lot of videos every day. And so you have to go to the website to see those videos, frankly, because YouTube is evil and cowardly, just like Google, the monster. It's all bad stuff. I'm not going to feed it. And I will oppose evil, because that's what I do. Oppose stupid and evil. Yeah, that's pretty much my life track and course. That's the vector I'm traveling. So anyway, till the next time and such. Okay, said that already. I have to get rid of this. Yeah, there I go. Okay, yes, I'm leaving. Okay, okay. Yeah, enough already. Yeah, till the next time and such.